The project is available, the document is up, but also I'm not logged in. Also the AutoGrader is live. You should be able to go to AutoLab. You have access now. You won't see that 500 error. You'll be able to go there and submit the assignment. There's one submission for the entire project. It's for all 6 lecture tasks and the application objective, the 2 application objectives. So as you're working on the project, as you get an objective done, right now you can just do the code for the first lecture task and after today the second lecture task without the functionality, without the testing. Man, this seems so loud. And you can submit as soon as you get that done, you can submit and see some feedback. Just the feedback about the parts that you did. So submit to AutoLab as soon as you have something is what I always recommend. You can submit as many times as you want before the deadline. So don't feel bad about submitting, seeing if you got the task or objective done before moving on to the next one. I also want to caution about the other side of that. Don't hit AutoLab too much. We see students who get up to like hundreds of submissions for a single assignment. At that point, if you're using AutoLab as a guess and check method, you're not really learning the concepts, and then the next homework's just going to be that much harder because you didn't get what I needed you to get out of that. See if I can adjust this mic volume. Here we go. Yeah, it's better. So don't submit. Make sure you're testing. We're going to emphasize testing starting next Friday when I show you how to do unit testing for your code. And we'll emphasize that in office hours. We're going to really hammer that down. If you come to office hours without testing your code first, the first thing we're going to say is, where are your tests? What did you do to test this? Why do you even think that this is supposed to work? But how do you know that if you didn't do any testing? So we will emphasize that. But you do have AutoLab there just for that verification. Okay, am I actually done with this? I've done all my testing, satisfies my test. Am I actually done? You submit to AutoLab. AutoLab says, yep, you're done. Then you're done with that task. All right, a reminder that I do have Discord open if you want to ask questions during lecture. My phone stops notifying me about stuff. Should our IntelliJ be set up already? I mean, it's recommended. You should have at least tried to set up IntelliJ by now. If you're having trouble, we do have a new Piazza post Nicholas put up that has more details, more clarification about how to set up your JDK and your Scala SDK. So if you're having trouble, check out that new Piazza post. And we also have Lab next week. Lab next week is dedicated to IntelliJ setup, and the document is up for that. You can look at that document for more help and more tips on getting everything set up. But you should have definitely at least tried it. If you don't have IntelliJ set up, if you ran into some issue, don't panic about it. Go to Lab next week, go to office hours as they become available, and we'll get you helped out. We'll help you out. You've downloaded all the things, but what's next? I would go through the lab document. The lab document will also show you how to access all the examples that I show in class, the repository with all the examples. I would get all that code and just start running some of my programs. And then, of course, working on the project, starting the project. Okay. Should we use JDK 15 Oracle or the Azul one? The Oracle one should work, but it's a bit more painful to set up. So if you want to go through the Oracle process, that is like the official, that is Java. But the Azul one is a lot easier to set up because you can do it right in IntelliJ. You can select Azul, it'll download it right in IntelliJ, link everything for you, and get everything set up for you. So if you don't want to go through that process, Azul will be officially endorsed by the course. I'll make sure everything works with Azul, which I haven't seen any issues yet, but if one does come up, that's going to be my problem, not yours. I'll make sure that I get my stuff working for that. And the next thing is to believe in yourself. Absolutely. Believe in yourself. You can make it through this course. This course is hard, but I always emphasize, as long as you put in the hours, you're going to be fine. Just put in the time that this course demands, and you're going to get through it. Believe in yourself and get through it. All right. Any other questions before we dive into content? Let's do it. So we're going to learn some more Scala today. This is going to be a blistering pace for a lecture, and also next Wednesday is going to be a pretty quick pace. That's mostly because I'm just going through, I said this last time, but I'll repeat it again. I'm mostly just going through Scala's syntax. I assume that you understand the concepts here. We will start seeing a little bit of new content. We will go a little bit deeper into some certain concepts. But it's really mostly still Scala syntax. Here's something that you know how to do. Today we'll cover data types, loops, strings, and reading files. You know how to do all those things in Python at least, and with the exception of reading files, you know how to do it in JavaScript as well. I just want to show you how to do it in Scala, with giving you some expansion on those topics. So it will be very fast. It's a lot of topics, a lot of concepts that we're throwing out there really quick. So just be prepared for that. The next lecture task, I did rename these lecture tasks. I forgot that I did that after homework 1 last semester, so I went back and retconned the homework document and the handout. If you cloned the repo before yesterday, make sure your testing suites are named lecture task 1, lecture task 2, not lecture objective 1 and lecture objective 2, which changing those names turned out to be more of a pain than I thought. Spent most of yesterday just updating my grader to replace objective with task everywhere that I saw it. But where a find and replace wouldn't have done the trick. But their lecture tasks, I didn't update this slide. I realized before lecture, I forgot to update this slide. Lecture tasks, a minor thing, but I overload that word objective so much that I don't want to keep overloading it. I want objectives to be, it doesn't matter. So the lecture task for today, what we want to get you to be able to do today is reading a file and doing some string parsing and a little bit of string manipulation. So for this task, we have a file in this format with country names separated by their country code, a 2-digit country code that are separated by this pound sign or hashtag these days, or number sign, depending on what, you probably all know them as hashtags, but depending on when you grew up, you call that thing something different. When I grew up, it was number sign or pound sign, but now it's hashtag. But anyway, that symbol. And your task is to write a method that takes 2 strings. One is the name of a file that has all the data of all these countries and country codes. And the second string is the name of a country. And your task is to return the country code for that country. And to do that, we have to do we're going to do a little bit of case manipulation. So the input can be any mixture of case. So for example, if the input is Japan with a capital P, or Japan in all caps, or Japan in all lowercase, no matter what the mix of case for the input is, those should all be treated as the same country. And the output country code must be 2 lowercase letters. In the file, they're all going to be uppercase country codes, so you have to convert those to lowercase country codes to return them. So a little bit of string manipulation, a little bit of string parsing, some file reading, some good stuff. So let's get you to the point where you can complete this lecture task. First, let's talk about types. On Wednesday, we saw that Scala is a strongly typed language. We really have to care about our types. So let's take a look at some common types that we'll use throughout the semester in Scala and talk about a little bit about what they are. All of these you should have been exposed to in 115. Granted, Python and JavaScript hide the types from you, so especially when it's the difference between an int, a long, and a double, you might not even know in your code because you don't really have to care about it in those languages. In Scala, we have to care, so we're going to look at that. We're also going to look a little deeper into what each one of these types really is and how they're represented in the machine. A little bit deeper than we did in 115, because in 116 we want to know how these programs work. We're in the program execution portion of the course, the program execution learning objective. So let's learn how our programs execute. And it starts with knowing how they represent information. So our first type is an int. An int is a whole number. Ints in Scala are 32-bit representations. These are signed values. So one of those bits is the sign, 1 or 0, whether it's positive or negative, and the other 31 bits are the number itself. So we can represent numbers from negative 2 to the 31 up to 2 to the 31 minus 1. We can represent all those numbers using an integer, but nothing outside of that range. So if you're using an int value, you have to be aware, you should at least, be aware that you have to be contained in this roughly negative 2 billion to positive 2 billion range. And once you step out of that range, stuff's going to break. This is what we call overflow or underflow. If somebody says your integers are overflowing, this is what that means. When you have the maximum value, if you exceed the maximum value of an int, so here I have an int that I'm setting equal to the maximum value that an int can store. If I just simply add 1 to that, this is going to overflow the integer and end up being equal to the largest possible negative value. It will wrap around to the negative value, and likewise, if you have that minimum value, if we subtracted 1, it'll underflow up to the maximum value. You can imagine how much this would break your programs. You would get something completely unexpected, not something that you want to run into in pretty much any case. This is how programs break. If you watch any speedrunners, sometimes this is one of the exploits that they'll take to use to break the game. They'll overflow some values or underflow some values, completely blow the game apart, and then blast through the game as fast as they can. This is what they're talking about if that happens. They're overflowing a value. That means that's an integer value, that they went over the maximum value that's allowed, then it underflowed, or they underflow it and get up to the maximum value. A long is just like an int, but we use 64 bits. I don't have a ton to say about longs. Whenever you think you'll exceed that 2 billion range, longs are sitting there waiting for you. For this course, the examples are set up so we'll use ints, and I just don't expect us to go outside of that range. But if inside your code you need a long for some reason, for whatever reason, those are sitting there giving you a much wider range that don't overflow quite as easily with low values like integers do. But most of the assignments will tell you to return an int or write a method that takes an int. I think I only have one place where I use longs, where we need longs, but I'll use ints. So even if you use longs internally, you have to comply with whatever the assignment's asking and return an int or take an int. But other than that, functionally equivalent to integers. This slide, if I could probably spend the rest of today's lecture on this slide, and a good number of you are still going to come to office hours with this problem. I'll be like, you're doing integer division. Integer division, if you divide 2 ints or 2 longs or any combination of those, the remainder will be deleted. If there's any remainder, if there's any fractional or decimal portion to the division, it's just completely deleted. You'll only get the integer portion. So if we have 245 divided by 12 in this example, we're only getting the whole number portion of the quotient. Any decimal portion is completely truncated, it's completely removed, and you won't get the exact answer that you're expecting. And this is different from Python and JavaScript. Python and JavaScript they have floats. JavaScript doesn't, the details don't matter. But they'll automatically convert to a floating point value if you do division like this. And in certain cases, if you want integer division, you can force it to use integer division. But they'll take care of this for you. Scala and most strongly typed languages will not. They're going to default to integer division. You try to divide 2 ints, the language is going to say, you're dividing 2 ints, you must want integer division. You must want the return value to also be an int. So we're going to give you an int as the return value. And to do that, well, we can't represent any remainder or any decimal portions. So we're just going to delete it. So it effectively takes the floor of the quotient and returns that. So if you're dividing 2 ints or 2 longs, make sure you are expecting that to be a whole number, or just at least understand that you're losing some information there. If we do want a decimal portion, we're going to use doubles. Doubles are also numeric types, but they're going to let us represent those decimal portions. These are 64-bit representations where we have 1 bit for the sign, whether it's positive or negative, 11 bits for an exponent, and 52 bits for a fraction. And this will, of course, all be in binary, and it'll be read as 1 point whatever this fraction is, multiplied by 2 raised to the exponent, the power of this exponent. You can think of this as scientific notation, where we have 1 point, 2 point, 3 point, whatever, times 10 to the whatever. We can think of that as the same way. This is 1 point, because we can't have a 2 in binary. 1 point this is the decimal portion raised to this power, and then positive or negative based on the sign. So we're representing basically binary scientific notation. And that's how our doubles are represented in the code, or in the machine. Since the way that this is represented, we will have loss of precision. So the way the decimals are represented are through this, the same way that we do in base 10, but through the addition of fractions of powers of 2. So if I have 0.11 as my decimal portion, that's the same as saying 1/2 plus 1/4 or 3/4. So I don't know if you've seen this in other courses or not, but I just want to give a very brief introduction in case you haven't. This is how decimal numbers are represented in binary. It's the same exact thing we do in base 3, where this is 1/10, this is 1/10 to the second, 1/10 to the third, 1/10 to the fourth. It's the same thing here, 1/2, 1/2 to the second, 1/2 to the third if we had another decimal. Same exact thing, just in a different base. We're in base 2 instead of base 10. So the implication of this is that there are certain numbers that we just can't represent. So in base 10, for example, the fraction 1/3, we cannot represent exactly like this. We have to go out to infinity, and we don't have infinite memory in our machine. We don't have infinite RAM to be able to store that value. At some point, we just have to say, you know what, that's enough. We're not storing any more decimals. We're just going to truncate the rest. The rest is just gone. And that's after 52 bits. Once we have 52 bits on the decimal, whatever's left just gets truncated, it gets deleted. We lose that information. So for example, the value 0.1 in base 10 can't be represented exactly as the sum of fractions of powers of 2. So 0.1 in base 10, if we convert that to base 2, which 0.1 in base 10, it's super easy. In base 2, it's going to be this value, which of course in double notation, the decimal would be right here. And then the exponent would be -4. But this is going to be what that is going to be represented as a double. So the value 0.1, if we put that value in a double, what we're actually storing is not exactly 0.1. We are losing just a little bit of precision. Not enough for us to really care about, but but we'll see some implications of this that will guarantee that we have to care about this, or else things are going to break. So here's just a quick 3 lines that you could type in you could create a main method and write these 3 lines and see this behavior. If I have these 3 lines, I'm going to have the value 0.1, which we know can't be represented exactly, and I'm going to multiply it by 3. So if you just print out B, it'll print out as 0.1. The computer will know how to, even though it's not storing 0.1, it knows how to display that to you in a way that's just 0.1. But if we multiply it by 3, we can start seeing that truncation error, what we call truncation errors. Multiply it by 3 and print that to the screen, and you'll see this. It's almost 0.3, but just not quite. It's 0.3, a bunch of zeros, and then a 4. Just not quite 0.3 like we'd expect. But we would expect it to be 0.3. It's close enough, right? Who cares? It's close enough. Why are we even talking about this? Where this really comes into play is if you're using those values to check equality. If somewhere in your code you say, if C equal 0.3, because I expect it to be 0.3, well, guess what? That's going to be false. You would want that to be true. You would want the body of your conditional to execute. But it's not gonna, because that's false. It's not equal to 0.3. It's equal to 0.3, a whole bunch of zeros, and a 4. That's enough for any programming language to say those are not the same value. because they're not. They're not the same value. Sometimes you'll get lucky and it'll just happen to be the same value. They have the same truncation errors. But the way we did the multiplication here is an example where it won't be the same. 0.3 is going to be truncated differently than 0.1 multiplied by 3. Just the way the processor works, the way the bits just happen to fall out, those will be two different values. So this is going to be false. C equal expected, false. You have that in a conditional, you're screwed. Where we're going to see this a lot is starting next Friday when we write testing, when we're doing unit testing, which will automate the checks to see if your code is correct. If in your testing you say, well, I expect the output to be 0.3, so I'm going to make sure that's 0.3, and if it's 0.3, the test should pass. If it's not 0.3, the test should fail. Well, if you're saying if it equals 0.3, that test is always going to fail, even if your code is absolutely correct. So that's something we absolutely have to avoid. How we do avoid that is by, instead of saying, are they equal to each other, we're going to take the difference between those two values, take the absolute value of the difference, which is the magnitude of the difference between these two values, and make sure that's less than some very small value. We usually call this value epsilon, and this value should be small enough that it's not going to interfere with the logic of your program. So for example, if epsilon was like 1, you could return the wrong answer and we'd still call it right because the difference would be, as long as it's not off by 1 or more, then it's still going to be equal according to this comparison. But you want to make sure that epsilon is large enough to take care of any truncation errors that you might come across. So we're going to say if these two values are at least within this value from each other, we're going to say they're effectively equal. They're equal within truncation errors, and we're good with that. Whenever you compare doubles, always do it like this. Maybe not exactly like that, but some way to take care of the truncation errors, to make sure the truncation errors are not messing you up. If you ever compare doubles with equal, and you come to my office hours especially, I'm going to make fun of you. I'm going to be like, you're comparing doubles with equal. I had a student last semester. I had a good rapport with them, so we were joking around a bit. Even towards the end of the semester, like every week, they would come into office hours, and I'd be like, you're comparing doubles with equal again. And I don't know. Don't do that. Don't be like that. Hopefully I got the point across to that student, but we'll see. We'll revisit this. I'll remind you of these slides when we do talk about testing next Friday. I will remind you of this. I'll go over this, review this a bit, because I know there's a lot of content in this lecture. I will review this part a bit, and then show you how this works inside a unit test. Okay, any questions? Looks like Nicholas has the chat. And calling it epsilon, that comes from the world of mathematics. They just decided that if we have a value that you expect to be very small, call it epsilon. Because they like to have single character names for everything, so epsilon just got reserved for that. So I borrow that from mathematics a bit. Serial guy Nicholas have chat. All right, let's keep going. Here's a few types that, well, at least Boolean, you should know. There's not much to say about Boolean. It's true or false. Lowercase t, lowercase f for what it's worth. So JavaScript capitalization, not Python capitalization, where Python wanted capital T, capital F. Other than that, I got nothing to say about it. The type is Boolean with a capital B. Booleans. Unit is when we don't have a type. Unit is just effectively the lack of a type. We'll use this as return types of methods. Every method has to have a return type. If you don't expect that method to return anything, like the two methods that we've seen already, printline and main, we don't expect those methods to return anything. Both of those methods return unit, just to say this method doesn't return anything. And when we call a method that has return type unit, we're calling that method for what we call its side effects. That method does something other than its return value that we're concerned about. With main, it's running the entire program. With printline, it's printing something to the screen. It doesn't have to return us anything. Just, hey, printline, print this thing to the screen. It doesn't have to report back to us. We get the side effect of printing something to the screen, and that's all we're okay with that. We don't need anything else from that method. So when we write methods that don't need to return anything, which we won't do until learning objective 2, we'll have them return unit and then call them for their side effects. Strings. Very relevant for the lecture task today. Strings are sequences of characters. This is true in probably every modern language. A string is a sequence of characters, which is a separate type, which is just effectively a single character string, but there are some differences if you dig really deep into it. Strings are declared with double quotes. In Python and JavaScript, if you've gotten used to using single quotes for your string declarations, none of that in Scala. Scala says double quotes or nothing. Single quotes are reserved for characters. If you have a single character, you can put those in single quotes to say this is a character, not a string. Not a string of length 1, it's a character type. Every string has to have double quotes around it. If you want a double quote inside of your string, you have to escape it with the backslash character. There are lots of methods. I'm not going to go over all of them in lecture. I'm not just going to drone on about you can do this with strings, you can do this with strings. That's what 115 was for. 115 does a good job with that. We talked all about different methods that you can call in strings. I'll highlight a couple here. Starts with, and then string. If you have a string and you do like s dot starts with valid as another string, that would return true because that string does start with that string as a substring. Length, if I do s.length, I don't want to count them on the fly, but it would return the number of characters, including spaces. Spaces are nothing special in a string. It's a regular character. It'll return the length of the number of characters in that string. And dot split, I'll show a few examples of using dot split because you'll need that for the lecture task. Dot split is going to take a delimiter, where it's just like dot split in JavaScript and Python. It takes a delimiter and returns an array of substrings of the original string split on that delimiter. There are a lot more string methods. I linked the official Scala documentation for the string class, and I recommend you go to that and look through. There are lots and lots of useful methods that you can call on strings that'll help you out in your programming. I'm not going to go over all of them, but you have a link to a comprehensive list of all of the string methods. Find the useful ones, find the ones you want to use in your programs, and use them up. Yep. On the course website. For this lecture, there's a link to the string class. All right, let's get into some sample code. If we want to convert between these types, so in Scala, Python, JavaScript, in a loosely typed language like that, you don't really have to think about type conversions. If you have a double and you call a method, oh, that's a bad example. Whatever. Sometimes we want to convert between these types. I'm just going to leave it at that. I don't need to give the whole background. So if we have these variables, an int, a double, a boolean, and a string, and we want to convert between them, Scala gives us a lot of useful to methods. We put the word to in front of the type that we want, and these types have a lot of methods built to switch between the other kind of base Scala types, and we call these methods without parentheses for what it's worth, and convert between the different types if able. So if there's a conversion that's coded in Scala to be able to convert from that type to the other type, then this is going to give you the value in that type. Now it has to be valid. So for this case, string.toDouble, converting a string to a double, is only going to work if that string is a well-formed double. So this string happens to be a well-formed double, 6.3. There's a very clear conversion from that string to a double. It's the numerical value 6.3. So in this case, our toDouble is going to be stored here. This is going to have the numeric value 6.3 as a double. If it's not a well-formed string, if it's like SIX.3, something like that with spelled out or whatever, or if it's just the string hello or something like that, you're going to get an error here. It won't be able to convert the type. and your program will crash. So, of course, be careful. Make sure you have well-formed strings. For most cases, for the homework assignments, I'll make sure all the inputs are going to be well-formed. So you don't have to worry about those. And you saw that in 115 and a lot of the UB infinite questions. It'll say you can assume this is a well-formed integer. And then we always get that question, what does that mean? It just means that you ain't got to worry about broken inputs. If you want to convert something to a string, everything will always be able to be converted to a string, and these won't error. You can always convert to a string. Every object in Scala guarantees that you'll be able to convert to a string, as long as you have an object, like unless you have something like null, I guess. But everything has a toString method, which gives you a string representation of that value. And then like doubles to ints, if you want to convert a double to an int, you can. This won't give you an error either, but it might truncate some information. So if that double has a non-zero decimal portion, you lose that. You effectively get the floor of that value as an int. All right, everyone good so far? Not too overwhelmed. It's a lot, but it's a lot of syntax. Hopefully you're fresh on the concepts. That's my assumption. If that's false, I would like to know. What are the single quotes used for again in Scala? If you want to, just a character, like the character just like a C, the character C or the character Y or something like that. You can put it in single quotes, and that says this is a char, which is a character, instead of a string. So if you want to specifically use the type char instead of string, you'd use single quotes. Yeah, are all the things we learned in lecture related to the lecture task? As much as I possibly can. Like some of the, like for example, today's lecture task doesn't use ints or doubles, but you will need to know that information for the future task. The rest of this lecture is all related to the lecture task, which is probably what you're all waiting for, so let's get on with it. For loops. You're definitely going to need a loop to do today's lecture task. But that is the idea, by the way. Here's the content that I need to cover today. Here's a lecture task, explicitly giving you practice with today's lecture content. So for loop, again, more syntax. I hope you all know what a loop is. Scala, the language names, Scala is more similar to Python in that you can only loop over data structures, whereas JavaScript gave you the option, and I'm assuming you all took 115 here. I know some of you haven't, so sorry for all the Python and JavaScript examples. I guess I could throw in Java. Java has very similar syntaxes similar to JavaScript in the examples that we're showing these in these early lectures. So if you had Java and jumped over 115, just ignore when I say Python and listen when I say JavaScript, I suppose. Scala does not have what I usually call a standard for loop. These were kind of newer-ish, but these are pretty standard now. What we call a for each loop, where you're iterating over a data structure. We used to only have the for loop where it's like for int I equals 0, I less than n, I plus plus. We don't have that style of for loop in Scala. That does exist in JavaScript and Java. We don't have that in Scala. We have to iterate over a data structure. There's no other option. That's how you loop in Scala. So the syntax for that is for, I misspoke a little bit there. There is a while loop which takes a Boolean condition, and you can kind of build a makeshift for loop out of that. But other than that, we have a for loop, for each loop only. So for, give it a variable name that you're iterating over, the data structure that you're iterating over, and this is the first of many arrows. The Scala language loves arrows. These little makeshift multi-character arrows. We're going to see these types of arrows. We're going to see the same thing, but with an equal sign, which we'll call fat arrows. They're going to be pointing left. They're going to be pointing right. We're going to have arrows all over, all up in here. There's going to be a lot of arrows. Here's the first one. It's a less than dash pointing to the left. This is read as in. So this is read as for variable name in this data structure, do this. And here's some examples using similar to range in Python, or simulating that for I equals 0, I less than n, I plus plus, simulating that in Scala. We can iterate over a range of values. So for example, here, I'm saying for my variable name, which I named I in this example, in a data structure with the values 1 to n in it, and then just print them to the screen because we're not doing anything too interesting now. I just want to keep my example small, so we're just printing them to the screen, not too interesting. This 1 to n, this next method does the exact same thing, but I'm expanding it a little just to show you what's going on there, because I said we're iterating over a data structure, and then I threw this 1 to n at you. 1 to n, this is actually a method call of the method to, which is part of the int class, which is being called on another int. So this is the same as saying 1.to and then n in parentheses, and that's going to give me a range data structure which contains the numbers 1 to n. And n in this case is going to be 10 because I'm calling that with 10 from the main method. So the main method, I call my method with 10 as the parameter, 1 to 10, and then prints out the values 1 to 10. But this does resolve to a data structure of type range. So I broke it into 2 lines, stored that explicitly in a variable of type range, and then iterated over that range, just to show you what's going on. We're iterating over a data structure, always, always, always iterating over a data structure, or more specifically, iterating over something that's able to be iterated over, something that gives us some data, even if it's not technically a data structure. Yeah, the variable, the previous slide, this is all abstract, showing the concept, and here's the concrete example. The variable name is I, the data structure is 1 to n, or the data structure is numbers here. I think that comment was just before I advanced to the next slide. This does include the last number. The to method includes the endpoint. If you don't want to include the endpoint, you can use until instead of to, and then it will exclude the endpoint. It'll include the first endpoint, but exclude the last endpoint with until. All right, now let's see an example that puts all of this together, and then we'll do file I/O quickly after. I got to remember when this ends. Ooh, 8 minutes. All right, so this example shows a little bit of a Rube Goldberg, but it shows everything that we've seen so far. We got a loop, we got a conditional, we got a couple different types, we got type conversions, we're avoiding integer division. So let's step through this thing and talk about what this is. So first, we want to write a method. If this were a lecture task, I would say write a method named compute%true that takes in a string as a parameter and returns a double. The double that it the string will be formatted as the string true or false. Any number of those separated by semicolons, and the return value should be the percentage of those values which are true. So on this string, true, false, true, 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 separated by semicolons, I would expect the value 0.8 to be returned. So that's our task. Of course, we have the answer. We're just going to look through how we did this. But that's the goal of this method. So let's go through this. Let's break this down. The very first thing I do, I have one string with a whole bunch of values separated by delimiters. The very first thing I want to do is split that thing up. I want to split it on my delimiter, which happens to be semicolon for this example. So I'm going to use line.split on semicolon, just like you did in 115. And that's going to give me an array of strings that are the splits that we expect. So we expect this splits right here to contain the strings true, false, true, 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 without the delimiters. It will remove the semicolons and give us just the values between the semicolons. And I'm going to initialize a few values here, a few variables. The total count, what I'm going to want to do is iterate over these strings and count how many of them are true and how many of them total I've seen. I'm going to do that with a loop. I'm going to iterate over some variables. I'm going to name my variable's value. This can be any name you want, whatever you want to name the variables that you're using to iterate over these values. In the data structure splits, I can't highlight these. This must be an image. No, I didn't do these as images. Anyway, yeah, I can highlight them. Must be selecting the green box. I can't do that. So we're iterating over this array. One at a time, we're going to look at the values in this array. And I want to convert the value to a Boolean, which is where some more Rube Goldberg comes in. We don't have to convert this. I could just say if value equal the string true, that would get me there. But I want to show a type conversion. So we're going to convert that to a Boolean using toBoolean, store it in a variable of type Boolean, and then say if that Boolean's true, which we can talk about more code tips, tricks, styles in 116 than we did in 115. I see a lot of students would put if value as Boolean equal true here. It's a Boolean. It's already evaluating to either true or false. Just say if the Boolean value. So if this is true, this is going to execute. We're going to increment our true count. If you haven't seen plus equals, this is going to add and reassign. It's going to add 1 to true count and then reassign that value back to this variable. And whether that was true or false, increment total count by 1. And at the end, divide, I got ahead of things. Divide true count by total count and avoid integer division. So notice that I could have total count and true count as ints, but I decided to set them as doubles. This is one way that we can avoid integer division, because if we have integer division, if we declare those both as ints, in every case, every input of this method, we're either getting 0 or 1. We'll get 1 if all of the values happen to be true, and 0 otherwise. Those are the only two values that we could return for this specific method. We don't want that. We want this to be a double. So I set these equal to doubles, even though they could have been ints, just to avoid the integer division. This is one way to handle it. No matter how you handle it, just make sure you avoid that integer division. Convert at least one of your ints to a double before the division, and you'll avoid that integer division. If you want to access the values after you split, another thing you have to do for the lecture task, you can access them using parentheses and then accessing the index of the value you want. So if I split this value 1, value 2, value 3 by underscores, and I want those values, I'm going to do splits of 0 is going to give me value 1. Splits of 1 is going to give me value 2. Splits of 2, value 3. Indexing starts at 0, something you should be very familiar with at this point in your careers. And finally, reading files. I won't get to the example in IntelliJ, but we will get through this last example so you can do your lecture task. Reading files, we're going to use our first imported library. This is part of the standard Scala library. The scala.io.source object, we're going to use this to read the files. This has a nice method named from source, and actually in this example, I meant to fix this slide. I apologize for that. I need to import this buffered source as well. If you are cutting and pasting this somewhere, you have to import that as well. If you're getting it from the examples repo, it is correct in the examples repo. So I'm going to call source.fromFile. That takes a file name and gives me a type of buffered source, which is giving me a way to read all of the content of that file. That buffered source has a method called getLines, which is going to give me a data structure of all of the lines of the file. And then I can iterate over those lines as strings. This is just like getAllLines in Python. So I'm going to iterate over the lines of the file. And then for this example, I'm not doing anything interesting. I'm just creating one string with all the contents of the file. Please don't actually do this. I say this every semester, and I always have people in office hours doing exactly this because they cut and paste my example. There's no reason to ever create one string. I shouldn't say no ever reason, but in this class, there's no reason to ever create one string with all of the contents of a single file. I'm only doing that to keep my example small, just so I can do something to show you how to iterate over files. You don't actually want to do this content plus equals line plus new line. There's no reason to do that. You want to process the data as you go. So for example, in your lecture question, you get your country name, you handle the case, which there's a method, convenient method, if you look through the string class, dot to lowercase. Get that in lowercase, look for the line in the file with that country name, again, to lowercase, and then get the country code. That's what you want to do inside your loop. You don't want to create one string with all of the contents of the file. Which brings us back to the lecture objective. And right on 240. Hey, all right. Have a good long weekend, everyone. I'll see you Wednesday.